So far, as we've been transforming functions, we have looked at a multiplier outside the function. And we said that controlled the vertical stretch, which we called amplitude. And we've looked at an added or subtracted constant outside the function. We said that controls the vertical shift. And we've also looked at a multiplier inside the function, which we used a Greek letter omega for. It doesn't really matter what letters you use because they all stand for constants. And we said that controls the horizontal compression or stretch, which we called period, or affected the period. And if you remember your pre-calculus 1, your math 141, you might remember that there's one more thing that we could talk about, which is just what about an add or subtract inside the parentheses. And if you follow the book, they use this Greek letter phi. It doesn't really matter what letter you use there. These could easily be A, B, C, and D. But the book uses a phi there. And this thing, since it's inside the parentheses and affecting the x, does affect the side to side, and it's a shift, not a stretch or compression. And this is what we'd refer to as phase shift. Now, the multiplier and the addition that are outside sort of have this natural separation of one being multiplied by the sine function and one not. Inside, it's not incredibly clear which way we should look at this. So let's just look at an example of saying sine 2x minus pi. So this is a function, and the exact same function could be written like this, sort of in a factored form. Notice if you distribute the 2, you get 2 times x is 2x, and 2 times negative pi over 2 still makes negative pi. So these are the same function. And the real question is, if you graph this, is it going to be shifted by pi, or is it going to be shifted by pi over 2? Oh, sorry, I'm getting some bad light on the page. Hold on. Okay. And it turns out the answer is that it's going to be shifted by pi over 2. So this is the phase shift, which means if you see it in this form, the unfactored form, you have to factor it to accurately see the phase shift. And I'm going to change my function up here at the top, my general function, to say you can't actually see the accurate phase shift until you put it in that factored form. So again, if you see something like y equals let's go secant of 4x minus pi over 2. You'll look at that and you'll say there is a phase shift, but it is not pi over 2 because this stuff inside here is not in factored form. So to see the phase shift, we have to actually put it in factored form. So we'll rewrite this function, factoring a 4 out. And factoring a 4 is the same thing as dividing by a 4, or multiplying by 1/4 might be the easiest way to think of it with fractions here. So this will become minus pi over 8. So this secant function has a phase shift of pi over 8. And keep in mind that things inside the parentheses work backwards from the way that you would expect. So if it's a minus and you sort of think that should mean move to the left, it actually means move to the right. It means all the x values need to be pi over 8 bigger than they were before to produce the same results. So when this is written up here in the general form, In the general form up here with a minus in here, that's accurate for saying this is the phase shift. So if it says minus pi over 2, then that's pi over 2 to the right. If it says plus pi, that would be pi to the left. That's the only new thing in 6.6. The book does some work with data analysis, which we're not going to do. So really this idea of phase shift is our last new thing for chapter 6. And in the example video, we'll look at a couple examples.